So I asked you how many were in here. So hopefully you wrote your number down. It's just a guess how many blocks are in there. I'm going to tell you in a minute. We are going to talk about something called the absolute guessing error, okay? Absolute value. Would you read it for me, Amy, please?
For 13.1.
Yep.
For this lesson, you were asked to guess the number of objects in the jar. The guesses of all the students have been collected. The teacher will share the data and reveal the actual number of objects in the jar.
Okay, so I'm going to give you that in a minute. I'm going to write down all your guesses, so hopefully you wrote that down. Continue.
Use that number to calculate the absolute guessing error.
Okay, so there's your new term. Absolute guessing error. You're going to put that on the chart. Continue.
Of each guess. How far the guess is from your actual number. Suppose the actual number of objects is 100. If your guess is 75, then the absolute guessing error is 25. If your guess is 110, the absolute guessing error is 10.
All right, so we are not concerned with any negatives. If it held 100 and you guessed 75, your guess is 25 off. If it's actually 100 and your guess is 110, the guessing error is 10. No negatives. Okay, no negatives. How far off are you? So let's hear some of your guesses before I give it to you. We'll just go around. Amy, what'd you guess?
26.
Georgia?
51. 42. 48. 52.
37. 54. 50. 50.
All right, it did want, I thought it said how many we should have here. Did you read how many?
At least 12 guesses, it says.
At least 12. Anybody else want to give a couple other guesses?
49.
49, 71, and 35. Okay? 2, 4, 6, 8, 10, 12. All right, so the guessing error then is going to be how far off is each guess. I'm going to let you fill that out. I'm going to tell you the actual number is 47. Okay, so I'm going to let you then figure out the guessing error. How far off is each guess?
Who guessed 48? Are we finding the absolute guessing error for all of them?
All of them, yep, all of them. And then we're going to plot them and look at the graph. Okay, we good?
Yeah.
Connor, can you give me the numbers going straight down, how far each one of these are? Again, it can't be negative.
21. 4. 5. 1. 5. 10. 7. 3. 3. 2. And I didn't get the last one.
24.
12.
Okay, thank you. Okay, so you notice guesses go on the bottom. I don't think we can go by ones. Can we go by 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, Twos would go all the way to 70. Want to do that?
Yeah.
Okay, go by twos on the bottom, we need to get all the way to 71. So we're gonna go by twos, so I'm gonna mark every 10. Twelve, 14, 16, 18, 20. Okay, guessing error. Might be able to go by ones there, we only need to get to 24. Okay, then I'd like you to put the dots on there from your graph. Guess of 26, 2, 4, 26, error of 21. So make sure you know if you're going by ones or twos. Please don't say anything about what your graph looks like. I would like you to get all 12 dots on there and then we'll discuss. Don't connect any dots. So plot the 12 dots.
Wait, where were you counting by on the y?
I went by ones. You should notice a graph here as you're putting your dots in, one like you haven't seen before. Maybe you saw it on the math test. But anytime you deal with something called an absolute value, this is the shape you're going to get. Anybody have theirs done? You got two dots that'll be in the exact same spot, that's fine. You don't have to put two there or anything. So here's what you should have.
They all go down, they all meet at 47 then?
Yeah, so we're going to discuss them now. We're on part 2 of the homework there, page 244. It says plot at least 12. We did that. Write down 1 or 2 observations. So what are some observations you have about your graph?
They all meet at the same, or they all meet at point.
Yeah, they're all heading to a certain point, right? Left side is decreasing to a certain point. Right side is increasing from a certain point. And what point is that?
47.
Why would it go to 47?
That's the number that.
Yeah. This number right here is where they're all going to. That's called the vertex. Okay, where our graph would start. Other observations?
It's not curved.
There's no curve. Yeah, it's all linear. Kind of two different lines. Okay, I can't draw one line and then go to the other one without switching directions. What kind of shape would you call that?
The V.
A V shape. So anytime you do these, you're going to get a V shape. There are no negatives. Okay, everything's on the positive side. It's just how far off our guess is. Anytime you do absolute value, always going to be that way. No negatives. It wants to know the distance from your guess to what it actually was. That's it. Distance is never negative. All right. Is this a function?
Yeah. Sure.
Okay. Does our guessing error depend on our guess? Absolutely it does. You gotta subtract it. Also passes the vertical line test. So it is a function. It is a function. For every guess, there's only one output, only one guessing error. Even though you guys had the same guess, your error was the same. Okay, that doesn't change. You can write skip by the are you ready, and we're going to do one more similar to this. Question 3 below that. Samantha, would you read that one, please?
Earlier you did the number of objects contained and you did the actual number. Suppose your teacher made a mistake about the number of objects in a jar. So we're going to correct it, the actual number of objects in a jar is.
Okay, so now in that underline, let's say I made an error in telling you, and I'm going to say it's 50. Okay, so on the back page of that sheet I gave you, change it to 50.
I have no sheet then.
Yes, I'll give it in a minute. Let's predict how our graph will change. I'm not letting you change your guesses. How do you think our graph's going to change?
There, all of that is just gonna shift over 3 spaces, but it's still gonna be like the same.
Okay, it's going to shift over spaces. Still going to be the same shape?
Yeah.
All right. So I'm going to put my guesses back up here. So you don't have to keep flipping the page over. So on the back page now, still write these. Change this number to 50. So your errors will change. And let's see if your prediction is right. So write down all those guesses again. Don't write down the errors because that's going to change. You're going to have to figure those out again. So your back page is going to have these written down, and you change this number to 50, then you need to calculate all those again.
What if they got it right, you just write 0?
Yep.
That was 2.
Just wanted you to see how that affects it. If you get it done, just let me know, and I'd like to share the group, share it with the group.
Wait, so if it's over 50, what would put it?
What do you mean if it's over 50?
Like 51, I guess.
That's only off by 1. Alright, you gotta change all those numbers. So this one should be 24, you know, how far is each one away from 50? That's what you're answering.
Which one, 24?
Yeah, so you probably want to erase all those if you just copied them down from last time. Maybe a little different. Jackson got them? Good. Prediction hold true?
Yeah.
Yeah, as you're finishing up there, I just wanted you to see. Okay, the number of dots on each side of the V might change depending on if you're on the low end of the guess or the high end. But now it's ending at 50. So that point is the vertex, 50, 0. And again, still makes a V. Still makes a V. So you said it would slide to the right, 3 spots, still be a V. You're correct. Number of dots on each side may change, but that doesn't affect our shape. And it doesn't affect our shape. But it would have been difficult if everybody would have been on the low end and then you wouldn't have seen this. All right, that's why it's important to have enough data so you can see both sides of it. Either way. If everybody guesses high, you're only going to see the right side. Okay, nicely done. That is absolute value. Distance away from an actual point. Okay, take a look at your homework then. Starting on page 233. What we did today on the first couple of examples, first 3 examples anyway, on absolute value. Question 4 is a review from lesson 3. 5 is a review from lesson 7. Those will be good for reviewing for the semester final tomorrow because those were previous lessons. 6 and 7, same thing. They are all from unit 4. Don't forget about number 8. Number 8 is the only one that comes from a previous lesson. That comes from unit 2. Changing equations. It is a select all. So 8 questions today for lesson 13.